quadratics. And we're just going to apply it to a new function. So it's not hard at all. What we're going to look at today is called an absolute value function. Now, what do you guys know about absolute value? In general, what does it do?
Gives you the absolute value of the number.
Okay, so it basically makes things positive, right? The math team shirts for this year, guys, are really cute. They're this. Wait, no, F of X. In case any of you were thinking of joining the math team, here's one more reason. This is what the short shirt says, and then it says, isn't that awesome? Thank you, Bridget.
I just love how you get so excited.
It's just kind of clever. All right.
I don't get it. Is that bad?
Well, I think you'll get it right after I go over this example. So, absolute value by definition really is the distance from 0 on the number line. So if we have 0 is our main point. When we have, let's say, 5, no, let's pick a different number, 4. How far away is 4 from 0?
4.
It's 4 units. This is 4 units away. So the absolute value of 4 is 4. Okay? Now, let's say we had negative 7. How far away from 0 is negative 7? 7 units. Okay? So, it's really, absolute value is a measure of distance and we know distance cannot be negative. A measure of distance from 0 on the number line. And that's not a hashtag line, that's a number. Are hashtags going out yet?
Yes.
They are out? Okay.
Well, I mean, I don't know. I never.
What is the newest thing?
Clowns.
Oh.
Okay.
This would be like, you can't, and like, I'm scared to even go out trick or treating on Halloween. Like, what if?
Were you planning on Halloween?
Yeah?
Were you guys
On Halloween.
old for trick or treating?
I think you might be a little old for trick or
You might
treating.
get some weird stares.
Yeah.
Really?
Oh yeah.
Where are you
I
gonna
was
be?
trick last year.
I think
Like the tooth fairy?
middle school is iffy, but once you walk through the doors of this building, your trick-or-treating days should really be over. When I go to the door and the person on my porch is bigger than me, I feel for them. I do. I'm like, wow, you can't go to you can drive yourself to the store and buy whatever candy you want. You're begging on my porch.
So,
We got
then what do we do
problems.
for Halloween, y'all?
You answer the door for the sweet little children that come to visit.
I like watch scary movies and
Stadium.
stuff.
That's what we do.
And this year you.
It's on Monday this year, so y'all don't do anything. Alright. Okay, so
Everybody's gonna be zombies on shit.
Football is usually on Halloween.
Ole Miss plays Auburn on Halloween.
absolute value of 5. What is it, guys? 5. Absolute value of negative 8.
8. Oh, I get it now.
Okay?
I still don't get the T-shirt.
Okay, it makes everything positive, so we're avoiding negativity.
Yeah, but it's just a positive X. It should be like a negative X, so it's like turns it.
Hey, I even understand that.
Oh, she called you really dumb.
Alright. Okay, so how many values of x would make this statement true? The absolute value of x equals 3. What can we plug in there for x that would make this true? Just tell it to me. What are they? 3 or negative 3. Okay, because both of those values are 3 units away from 0 on the number line. So with the absolute value, a lot of times we get 2 possible answers. Okay? Alright, so let's graph it. And this is probably other than a line, probably the easiest graph we'll do. So the first time we graph something we're not familiar with, we generally like to make a table. So let's make a table of values, and let's try -3, -2, -1, 0, 1, 2, 3. These are always my favorite. And unless something's been shifted around, this usually gives us a pretty good indication of what the graph looks like. If it's been shifted around, we may not have an indication of all of what the graph looks like. Alright, so if we take the absolute value of -3, what do we get? 3. Absolute value of -2.
2,
-1.
1,
0.
0,
0. 1.
1.
2.
Oh.
No, it's positive.
Oh.
Because it's a distance. So whether we take the absolute value of a negative or the absolute value of a positive, it's always positive. Okay. Yeah. We skipped because of leap year this year.
What you said?
Usually you just go by 1, but we bumped up 2 because of leap year.
So it was on Saturday night. Flash.
Okay. So let's graph it. Switching colors so it's easy to see. So let's see, we've got -3, -3 is probably where I should start. -3, +3, excuse me. -2, +2, -1, +1, 0, 0, 1, 1, 2, 2, and 3. Now I like this one because this is the victory graph, which is what's going to happen Friday night when we play Whitewater.
I wish we could have videoed you.
Woo!
I like
Y'all can clip that from my video today and send it to anyone.
We can put it on the PA system at the
Alright.
victory formation.
that. Like if they're trying to talk trash and you guys are in victory formation, Miss Willoughby says this is victory graphical.
Alright. So, here we go. There's no restriction on anything we can input into this function. There is no restriction on the domain. So it goes from -infinity to +infinity. Now, the range, our output. Because we're doing absolute value, and this is our parent graph, we're not getting any negative values out. Because when we take the absolute value, they all become positive, right? So, going from 0 to infinity. Now, if we shift the graph around, like if we drop the graph down 5 units, we can get negative values then, because we've shifted it. But if it's the parent graph, we can't get out a negative number when we take the absolute value. So our vertex is the point 0, 0, and just like with a quadratic, our vertex is always going to be the max or the min. In this case, it's the min. Whenever it opens up, that point is the min. If our absolute value graph opens down, it is the max. Now, this ray, which is part of our absolute value, has a positive slope, and this one has a negative slope. And what you're going to notice is they are always opposites of each other. So this one has a slope of +1, this one has a slope of -1, and every single time those two rays will be opposite. And that's going to be important when we start writing it as a piecewise function. So this one's increasing over here from 0 to infinity. Remember, intervals of increase and decrease, we describe those intervals using our x values. And this one's decreasing from -infinity to 0. This graph only has one x-intercept and one y-intercept, and they both occur at the origin. And every time both ends of an absolute value will go the same direction, so we can kind of cheat and write it a little shorter. We can say as x approaches positive or negative infinity, y, in this case, is approaching positive infinity. Okay, this function is greater than 0 everywhere except the vertex. At the vertex, it's actually equal to 0. It's not greater than. So we can say, where's the function positive? Everywhere but 0. From -infinity to 0, union with from 0 to infinity. So where is it negative? Nowhere. E. Now, absolute value functions can be even. And this one is. Because it's reflective over the y-axis. So, if our absolute value function is not shifted left or right, if it's shifted up and down, it's even. But if it's shifted left or right, then it's neither. So it's either even or neither, and it depends on how it's shifted. Bless y'all. Is this corner okay?
Yeah. Where's this Mitchell?
Just Mitchell? We got some Kleenex. And gentlemen, we have some hand stuff back there. Alright.
Yeah, I think you got some.
Oh, you guys are making me.
But
Mitch, you're fine.
Okay. Let's look at the examples on the back. We're not going to do all of these, and we'll see how many we can get to in terms of time. But I would like to do 5 of them, but we'll see. Alright, this one. Okay. Thinking back to what we talked about with quadratics. Same idea. Do you see the 2 is in there with the x?
Yes.
So, we always do the opposite. So this one's going to move
It's escalated very high.
right 2. Okay?
How did you get it on yourself?
I squirted it and it just shot.
Alright.
Amateur hour, jeez.
Today's comic relief is provided
Shut up
by
your nose next time.
Okay, so
Spread it.
here we go. We moved right 2. And we're just going to do those normal moves. The absolute value of 1 is 1. If I move left 1, the absolute value of negative 1 is 1. The absolute value of 2 is 2. The absolute value of negative 2 is 2. Okay? So, every time we're going to get a pretty V for victory over Whitewater this weekend.
Woo!
Okay. There we go. Alright, so our domain. If you are just given a function and it's not in context of anything, our domain of an absolute value will never be restricted. It will always be from negative infinity to positive infinity. The range for this one, because it was not shifted up or down, is the same as our parent graph, from 0 to infinity. But we did shift it right, so our vertex changes a little. It's still a min. I meant to underline that, not scratch through it. And the minimum value is 0. So this one is going to increase from 2 to infinity since we shifted it. And it'll decrease from negative infinity to 2. The vertex is sitting on the x-axis, so that's our only x-intercept. And our y-intercept, we can clearly read it off the graph. It is 0, 2. But if we could not clearly read it off the graph, we can plug in 0 for x. And then we get the absolute value of negative 2, because 0 minus 2 is negative 2. And the absolute value of negative 2 is 2.
2.
Alright, end behavior. As x approaches positive or negative infinity, it's opening up, so y is approaching positive infinity.
So you can do it like that and only have to write once?
Yeah, let's take a shortcut.
We're supposed to do that on the quiz?
You could have.
If the ends are going the same direction, I'm okay with that.
I'm more old school.
Sure. Alright, where's the function positive? Every place but right here at 2. So from negative infinity to 2, union with 2 to infinity. Where is it negative? It's not.
So the end behavior is always going to be like that.
Both ends of an absolute value function always go the same direction. So this part will always be the same. And anytime it opens up, y is approaching positive infinity. But you're going to see down at the bottom, we have a negative out in front of one of them. So instead of opening up, it opens down. And so that would change that to negative infinity. Alright, and because this one's been shifted right, it no longer has symmetry about the y-axis, so this is neither now. Alright, the next one. This minus 3 is not inside with my x. So that affects my up and down. So it's going to drop it down 3. So my vertex is now at the point 0, negative 3. And then absolute value of 1 is 1, absolute value of 2 is 2, absolute value of negative 1 is 1, absolute value of negative 2 is 2. And these moves are always made from our vertex. Moves from the vertex of the function. So let's hit that victory over Whitewater. Right here.
You must really hate Whitewater.
Well, I don't hate them.
I do.
I just,
I do.
I don't appreciate the social media post I just read, so.
Ooh, what did they say?
So,
Beer balls
Alright.
Print it out right
Domain is from negative infinity to positive infinity, and the range is from negative 3 to infinity. That vertex is a mid. It is increasing from 0 to infinity. That's where my positive slope starts at an x value of 0 and goes to infinity. My negative slope was over here at negative infinity to 0. That's where my function was decreasing. Now, this one has more than one x-intercept. It crosses at negative 3 and again at positive 3. Now, this one's nice because it crosses perfectly. But to find the x-intercepts, we could just say that's a y value of 0. And to solve this, I would add 3 to both sides. So I get this equation. 3 equals the absolute value of x. Well, we've already talked about this. What are the possibilities? Negative 3 and positive 3. So we can either solve it algebraically or look at our graph. And we can do the same thing with a y-intercept, because with a y-intercept, we just plug in 0 for x, it goes away, and we're left with
Negative 3.
negative 3.
Classic.
Okay, in behavior, as x approaches positive or negative infinity, y approaches positive infinity. Now, positive and negative, yes.
Are you gonna like take this to the office or something?
No,
Oh.
I mean, it's just good old-fashioned hate.
They don't say any cuss words or anything. So
No.
we're good.
No, there's no threats
This is
or
awesome. You put it all.
there's,
Yeah. We just
there's
gotta be
nothing.
sissies and just sell it in
that's-
the field.
It's just
The
some
threat
people
is
are a
not-
little too big for their britches.
Bro, that's a threat. They can't live up to.
Alright, so where's the function positive, where's the function negative? It is positive from negative infinity to negative 3, and then again from 3 to infinity. It is negative from negative 3 to positive 3. Does that make sense? Okay, so positive and negative, greater than 0, less than 0. Greater than 0 is talking about what are the x values where it's above that x-axis. So this part right here is represented by this part. And then this part over here is represented by this part. Those are the x values. So where is the function less than 0? That's below the x-axis. So from an x value of negative 3 to an x value of positive 3, this graph is below the x-axis. It is less than 0. Okay, now since this one was just shifted down, it is actually still even because it is symmetric over the y-axis. What I'm grading when I grade these are the actual dots you put in. And we can pick up some straight edges to do this. That makes it a lot easier to draw our lines properly. Alright, where is the vertex for the next one? Where's it start?
Left.
Negative 3,
Negative
positive
3,
2.
positive 2.
Okay, so negative 3, positive 2.
Oh, they can't stop us.
Alright, what time is this class over?
51.
Oh, I'm doing great.
Or 53.
I don't have to rush through, sorry.
You know,
You
just,
can rush.
just one more period down until Whitewater gets over.
That's not true, Hayes. We have true.
One more math class.
Yeah.
Oh, okay.
No, I'm talking about like one more period out of the.
Alright,
however many more we got.
so domain.
Negative guy.
Negative infinity to positive infinity. What's the range on this one, guys?
Negative.
Range is always our y's.
2
So it
to
is
infinity.
2 to infinity.
And there's a bracket, so it includes it. Oh, that hurt.
Alright, this vertex is still a min. We haven't done one that opens down yet. That's next.
Yep.
Increasing is from the x value to infinity. That's the positive slope side. The decreasing is from negative infinity to the x value at the vertex, because that's the negative
Yep.
slope side. X-intercepts. Zero. There's nothing. None. Okay? Now, I told you how to do it algebraically earlier. So what happens when there's a none? okay?
You don't gotta do it.
Alright, so we get 0 equals the absolute value of x plus 3 plus 2. What happens is we move this 2 over, and we get negative 2 equals the absolute value of x plus 3. Is it possible to take the absolute value of something and get out a negative number?
No.
No, there are no solutions, which tells us there are no x-intercepts.
Well, what if
So even if I just gave you the equation and didn't give you a chance to graph it, you could tell me there are no x-intercepts because this is not solvable. We can't solve for an absolute value equal to a negative number. Alright, my y-intercept, I do have one of those. If I plug in 0, I get 3 plus 2 is 5. In behavior, as x approaches positive or negative infinity, y approaches positive infinity. And where is the function positive? Everywhere. Even the vertex. So it's from negative infinity to positive infinity. Every point on that graph lies in a positive region. So there's no negativity here. We're avoiding it. Alright, so this one's neither.
Get it? Because the t-shirt said
It sounds like a chipmunk.
Alright, what's gonna happen is one day, like 20 years from now, somebody's gonna tell a corny silly joke and y'all are gonna think of Miss Willoughby. And hopefully smile instead of saying bad words. Alright, this one. Which way is this one gonna open, guys?
Down.
Down. What makes it open down? It's negative. So if we go over to 2, 3, which is our vertex, instead of going up, we're going down. Alright, domain's not going to change. Range this time does though, because it goes down forever. So the lowest point is negative infinity, and the highest point is 3. So it's negative infinity to 3, the lowest y value. All the possible y values go from negative infinity to 3. So this time, that vertex is the max. Whenever it opens down, your vertex is the highest point on the graph. It is the greatest y value. And it is increasing from negative infinity to the x value, and decreasing from the x value to positive infinity. So it's flip-flops. Now this one has 2 x-intercepts. We can solve algebraically, but we can see them on the graph. So let's list them, -1, 0, and 5, 0. I need to extend that line a little bit so you can see them. Here we go. The y-intercept is clear on the graph, so we don't have to solve for it, but we could. The end behavior, this time as x approaches positive or negative infinity, y approaches negative infinity. So this one is positive from -1 to 5, and it is negative from negative infinity to -1, and then again from 5 to infinity. And because it's been shifted left or right, it is neither even nor odd. Now the last one, I'm not going to do all this stuff, but I do want to talk about something that's kind of cool about these. Have you noticed that the slope of every single one that we've done so far has either been 1 or -1, depending on what side of the absolute value, which ray you look at?
Absolutely.
The slope of this one's going to be 2. And so the slope ends up being the same as the scale factor.
That's absolutely right. Get it.
So this one would be at -3, -2, and our moves are doubled. So instead of over 1 up 1, we go up 2. Instead of left 1 up 1, we go up 2. And we double those moves because of that 2. Instead of going 2, 2, we go 2, 4. 2, 4. So when you investigate the slope of this graph, you'll notice that the slope is +2 on this side and -2 on this side. The slope is going to match our scale factor.
So what do you do with this?
That just shifted the vertex. That just makes this start right there. So we start right here, and instead of doing plus or minus 1, 1,
Go up.
you do plus or minus 1, 2. Instead of plus or minus 2, 2, we go plus or minus 2, 4. And all of that is because we're doubling the y's. Okay, the other 3 little problems, those other 3, that's your homework. And so it really shouldn't take you more than like 7 minutes at the most. The second sheet, did you pick up a second sheet? That's all right. Anybody else need the second sheet? These 3 are your homework.